Most would say it's impossible, but Air Force engineers have demonstrated just how far technology has come in recent years by doing the unthinkable. Using sophisticated software and tools, they repaired a damaged military plane deployed in conflict zones, for example in Afghanistan, from a rather odd location, their bedrooms. If you thought work from home was limited to IT jobs and freelancing, you're in for a surprise. This revolutionary engineering approach is being hailed as a breakthrough in remote engineering. But how is this possible? Let's find out. The A-10 Thunderbolt II, also known as the Warthog, is highly durable and versatile. Designed and used by the U.S. Air Force, it was first developed in the 1970s and is now one of the most recognizable aircrafts in the military. It is a heavily armored, twin-engine attack aircraft designed to support ground troops in battle. The A-10 is primarily used for close air support missions, providing effective firepower against enemy infantry and tanks. The GAU-8 Avenger 33mm gun, the aircraft's main weapon, is at the focus of the design. With 7 barrels and a massive ammo feed mechanism, this armament is so big that the plane was designed around it. The gun's primary objective is to destroy enemy armor. The A-10 is also known for its incredible toughness. It can withstand heavy fire and return to its base safely even after being severely damaged. This resilience has earned it the nickname Warthog from its pilots. But even the toughest of planes can fall victim to battle damage. So, what happens when an A-10 is damaged in combat and needs to be repaired? The Air Force Lifecycle Management Center engineering team at Hill Air Force Base was tasked with an unusual challenge: repair a bullet hole in an A-10 Warthog without ever seeing the plane. They employed a combination of remote and traditional engineering methods to accomplish this. Repairing a battle-damaged A-10 Warthog remotely is no easy task. While the Air Force engineers had the right tools and knowledge, they still faced a major challenge in completing the repair mission. Firstly, the aircraft was thousands of miles away, meaning they had to remotely operate the tools they used to do the repair work. Secondly, they had to carefully monitor the aircraft's vital systems while making the repairs. This meant they had to have intimate knowledge of all the aircraft's systems, ensuring that the repair attempt wouldn't cause further damage. Where is this remarkable engine feat taking place? Instead of in a workshop, it's happening from the bedrooms and living rooms of Air Force engineers all around the country. The engineers responsible for repairing the battle-damaged A-10 have been able to do so with the help of a wide range of modern tools and traditional methods. These include 3D scanning, 3D printing, and computer-aided design, or CAD, software, allowing engineers to accurately measure and create the needed parts. They also use sophisticated digital cameras and software that allow them to view the plane in detail from any angle. Additionally, they have access to powerful microscopes, enabling them to examine the minute details of the plane's components. After a detailed inspection, the engineers found a crack in the plane's structure with 3 sheared fasteners and a bullet lodged in the fuel cell cavity floor crack. The repair process has been carefully planned, with teams of engineers and maintainers throughout the United States working together remotely to get the aircraft up and running again. The teams have established secure connections using remote access technology to review documents, diagrams, and blueprints while communicating via video chat. The maintainers can also access specialized equipment in military bases, allowing them to complete the tasks. They received tips for getting the exact shape needed to ensure a snug fit for a patch around the bullet hole. Finally, once the patch was installed, it was tested for structural integrity and quality assurance. The engineers provided detailed instructions on installing the kit and ensuring it was properly secured and sealed. These materials were then sent to the Air Force Base near the damaged aircraft, where technicians deployed to the site used them in the repair. With all these tools at their disposal, the engineers have been able to repair the A-10 from the comfort of their bedrooms. Without ever having to step foot inside the hangar where the plane is kept, the engineers have used these technologies to diagnose problems, plan repairs, and manufacture new parts. By using CAD software, for example, they can create an accurate model of the damaged part and then print it out using a 3D printer, all without ever leaving their home. Not only does this method enable them to keep costs down, It also makes repairs much faster, allowing the Air Force to get planes back in action quicker than ever before. Furthermore, this method ensures that repairs are done safely and efficiently, as engineers can stay away from potential hazards while maintaining a high level of accuracy. Remote engineering has thus proven to be a great asset to the Air Force, saving both time and money while still providing quality repairs. The team's hard work paid off, as the repaired aircraft was able to take off again with minimal disruption to its mission. This successful repair is a testament to the power of remote engineering and how it can be used to solve challenging problems in unique situations. If you're still watching, you're probably a fan of the expression, "the devil's in the details," because we're about to spill the deets. Here's what the process for this air repair actually looked like. The first step in the repair was to assess the damage. The engineers inspected the damaged parts of the aircraft remotely via digital photographs. They then took measurements of the damaged parts and developed a repair plan. The plan included creating a 3D model of the part, designing a new prototype, and 3D printing the art. After designing the part, the engineers had to ensure that it would work properly and meet the required specifications. To do this, they used software simulators to test the part in different scenarios. This verifies the design and lets us know that the part can withstand the forces of flight and meet its intended purpose. Once the part passes the testing phase, it is printed and sent to the airbase. At the airbase, technicians install the part on the aircraft and test its performance in real-world conditions. If all goes well, the aircraft is ready for action again. This process has enabled engineers to work more efficiently and effectively, saving time and resources in the process. Thanks to their hard work and ingenuity, these engineers are making it possible for the aircraft to serve in combat once again. It may not be the traditional way of repairing an aircraft, but the work of these engineers is just as important to get the Warthog back in the air. The repair effort has been a success, and the A-10 Warthog is now back in service and will be fully repaired once it arrives at its home base in the US. This method of remote engineering has proven to be an efficient and cost-effective way to maintain and repair military aircraft. As the Air Force continues to look for ways to reduce costs and streamline operations, this method of remote engineering will likely be seen more and more in the future. The unprecedented collaboration between Air Force engineers and their colleagues around the world to repair a battle-damaged fighter plane from their bedrooms is a remarkable example of what can be achieved when faced with challenging circumstances. It demonstrates the power of modern technology, as well as its potential to connect experts regardless of their location or time zone. This kind of remote collaboration could become a model for the future, allowing experts to lend their expertise halfway across the world without leaving their bedrooms. Imagine taking this even further. What if in the future, doctors perform surgeries remotely from home in their pajamas? How wild would that be? Definitely let us know your thoughts in the comments below. In recent years, remote engineering has become an increasingly important tool for the Air Force. As technology continues to advance, here are a few potential future developments that the Air Force may be exploring in remote engineering. Artificial intelligence and machine learning. These technologies could be used to analyze large amounts of data from aircraft systems, helping engineers to quickly identify and diagnose problems. This could also lead to the development of predictive maintenance, where aircraft systems can be proactively maintained before they fail. Augmented reality. Augmented reality, or AR, technology could provide engineers with real-time information and instructions while working on aircraft systems. This could make it easier for engineers to access and control equipment and make repairs more efficiently. Blockchain. Blockchain technology could be used to securely store and share data between different aircraft systems. This could help to improve data security and protect against hacking and cyber attacks. 5G networks. With the deployment of 5G networks, remote engineering will be more efficient and reliable. The high speed and low latency of 5G networks will allow engineers to access and control aircraft systems in real time, even in remote locations. Advanced robotics. Robotics could be used to perform remote repairs on aircraft systems, reducing the need for human engineers to be on site. This could make repairs more efficient and reduce the risk of injury to personnel. It's important to note that these are just a few examples of potential future developments in remote engineering, not only for the Air Force, but industries across the world. With the rapid progress of technology and the increasing demand for remote engineering solutions, it's clear that the Air Force will continue to invest in this technology to improve aircraft maintenance and repair. But if even this wasn't enough detail for you, we suggest you take it up with the US military. Now check out these videos.